Oh crap, I wore my red shirt! I'm just gonna have to take that risk. Quantum teleportation to space has finally been done successfully. Super exciting, but it is quantum, which means we didn't teleport a thing per se, but some data. Basically, Chinese scientists beamed photons from the ground to a satellite orbiting above the Earth, then they messed with them using quantum entanglement. Entanglement we've talked about before. Einstein called it spooky action at a distance, and it happens when you have two particles, usually photons, that are created together. They're like twins, and their twinning can stretch across space and time, like me and Mark Ruffalo. Because they were entangled, when the scientists observed the spin of the Earth photons, they could also know the spin of the photons in space too. They spin in the exact same way, even though there's no physical connection between the two. They're just mimicking each other. How? No one knows. It's spooky action. They're like telepathic twins in different cities, like me and Mark Ruffalo. In this case, the Chinese satellite was capable of sensing the quantum state of the photons, so they could prove that the photons were entangled, even across a vast distance, hundreds of miles. So think about this for a minute. Right now, if I want to send a message, I have to secure it with encryption, like over secured Wi-Fi or radio waves. But if we could make entangled phones, say, when my quantum particle moved, yours would move, if we could take advantage of that, we could communicate without any perceivable physical interaction. Of course, we're totally not there yet. Quantum states are detectable, but by the laws of quantum mechanics, once we observe a particle, it changes. The nice thing is, entanglement means we only have to observe one of the particles to sense the state of the others. But it's not two-way data transfer. Not yet. So, we teleported information to space, which is a humongous accomplishment. But the practicality of it is still up in the air. Quantum mechanics is still bound by the same laws of the universe's regular physics in some ways. So we couldn't use the particles for, say, faster-than-light communication. But we could use them sort of like decoder rings. For example, if a spy has one of a twin set of particles and their contact has the other, alongside each could be a coded message. If they meet, observe their particles and the spins match, they'd know no one had tampered with their messages. It's the ultimate security. Companies are already working on quantum entanglement as a security protocol for the future internet. Quantum entanglement could lead to moving data without wires or wireless frequencies, and because anyone who somehow observed the entangled photons, i.e. spied on them, would alter them, security could be incredible. The problem is, quantum mechanics is not fully understood. This is very much like trying to create a whole new type of computer without fully understanding computer chips, or like building an airplane without understanding air molecules. Still, some Dutch researchers plan to start the first rudimentary quantum computer network very soon, and they are not alone. It's a huge engineering challenge, and it's not impossible, but it is really hard. Success, though, would most definitely change the world. A quantum internet could change our banking system. Security would be way better, but you'd still need to balance your books. FreshBooks is an online invoicing and accounting software that can help. Their software lets you manage your finances or finances for a business. You can send clean and professional-looking invoices in about 30 seconds. With literally 2 clicks, you can set yourself up to receive payments online. You can even take pictures of receipts on your phone using FreshBooks' mobile apps. This makes claiming your expenses a million times easier. For a 30-day unrestricted trial, go to freshbooks.com/seeker and enter Seeker in the How You've Heard About Us section. If you like this video, please take a second and subscribe here. And Crystal here can tell you about how quantum computing actually could work. Click it. One last fun fact. In this Chinese experiment, the team sent millions of photons to their satellite to measure them, but the satellite only caught 911. So again, it's a tough way to send information, but it's not impossible.